Okay, hope you all had a wonderful lunch. My name is Stan Barber. I'm the chairman of the Texas IPv6 Task Force, one of the task forces that are working to put this on for you today. So we appreciate you being here. The awards that everyone's been talking about are still on a FedEx truck running around in Sunnyvale right now, and they don't have IPv6, unfortunately, or I could get them redirected appropriately to this location. We'll have to wait until they deliver wherever it is they're going to deliver, and then we'll be able to retrieve them and award them to the wonderful folks who have done such a great job getting V6 to the various consumers of the internet. Anyway, enough of that. I'd like to introduce to you a gentleman who worked with me to found the Texas Task Force several years ago in, of course, Texas. We met in San Antonio at an ARIN meeting and thought it would be a good idea to promote V6 in the Lone Star State, and subsequently organized the task force and held several events in Texas. The last one we held, I think, was with Vint Cerf at the University of Texas at Dallas, which strangely enough is located in Richardson. Don't ask me why. We were hopeful that we might have another event there again, perhaps next year. So if you are in that part of the world, hopefully you'll consider taking us up on that when the time comes. Nonetheless, Stephen moved on, went to work for a large company in Washington that you probably heard of, and then moved on to even a better company, T-Mobile. And those of you who are T-Mobile aficionados can actually use your T-Mobile Tuesdays to get your free gift from them today. So don't forget to do that. Can't promise it's an IPv6 gift as far as I know, right? But Stephan will be here to speak with you about all the wonderful things that T-Mobile has to tell you about V6 in their environment. So, Stephan?
Thank you. Thank you. Can you guys hear me okay? Thanks. Everybody can hear me okay? Yeah, sounds good. I'm going to try to do this from my phone here, so hopefully we're not going to run into any major issues, but if we do, I'll switch over to the laptop here. But I want to talk today about going IPv6 only. I've only been with T-Mobile for about 6 months, so I can't take all the credit, or I can take very little credit of it. But it's nice to be here and to talk about what we've done. And as Stan said, I met Stan in 2008 at the ARIN meeting in San Antonio. And we were kind of impressed. The Rocky Mountain guys, they've been doing some V6 things, and I came from Sweden. I moved to U.S. in 2007, and at that point, Sweden was ahead of U.S. in terms of IPv6 deployment. A lot of universities in Telia, which is the main service provider in Sweden, they've done some experiments and they had some stuff going on there. But in U.S., we didn't really see that. So in 2009, I snatched up the txv6tf.org domain, and I met Stan again at the Google conference here in 2009, and that's kind of when we said, hey, let's form something in Texas. And Stan had some experience working with nonprofits and filling out all the different forms for IRS and so on. So, of course, we voted him being the chairman. I was the vice chair for a while. Anyway, from there, I started work for a company called Secure64, a DNS company, because I'm kind of a DNS guy. And then around 2010, a sales guy from this company calls me and says, hey, I got these guys on the hook, T-Mobile. And this guy Cameron, he's talking about doing IPv6 only and DNS64. I have no idea what he's talking about, but he's going to need our help, and you need to call him up. So I called this guy up, Cameron, which I now work very closely with. And And I knew about IPv6, of course, you know, and I founded the task force. I knew about DNS64, NAT64. I thought that that was something that you could use in a lab or something to test v6 only. I never realized that anybody was crazy enough to try to do this on a large scale, like a T-Mobile scale. But Cameron convinced me that this is a good thing, and actually Secure64, we didn't have any products for DNS64 at that point, but we created one, and we had a first commercial DNS64 product in 2011, and T-Mobile became a customer of Secure64, so that's how I kind of met the folks at T-Mobile. Then in 2014, as Stan said, I moved to state of Washington. I moved to work for Microsoft. I ran the DNS for Microsoft and Skype and all the public-facing DNS for them for about 3 years. And then in December of last year, I moved to work for T-Mobile. And Cameron, you know, first thing he tells me is, "Oh, glad you're here, and good to see you guys again, and see you again. And you know, by the way, we're turning on v6 only here on the iPhone soon, so you know, we got some work in front of us to figure all that stuff out." So I've been doing some work around that lately, and I want to talk a little bit about us going v6 only. So I'm not going to talk much about dual stack. So I'm talking about v6 only, which is really what we want to accomplish. And that's where you start to see the benefits with v6. Running dual stack costs you as much as running v4 plus some extra to run the v6. Running v6 only, that's when you can really see the gains. So here's my contact information. I'm managing a team of network engineers at T-Mobile, and we're responsible for the architecture of the T-Mobile network. You can reach me here if you want to. And by the way, I'm hiring some network engineers. So if you want to move to Bellevue, Washington, let me know. I'm going to talk about our journey, what we've accomplished so far, and some background about DNS64 and 464 XLAT. That's the technologies that we're using predominantly. I'm going to try to do a live demo of some interfaces on my phone. We have a pretty complex setup here with the Chromecast and then my Samsung phone tethered to Dan's AT&T iPhone up there and back. So we'll see how this goes. Worst case scenario, there won't be any demo. But if anybody is interested in tagging along, you can always download this. I use this Network Info 2 app, and you can get it from the App Store and download it, and you can kind of tag along. Even if you're not a T-Mobile customer, you can see all the interfaces there. And by the way, how many do we have in here that's T-Mobile customers? It's a few of them. And how many of those are using an iPhone? So we have 4 or 5 people here in the room that are actually, if you've upgraded your phone to 10.3, which you have, unless you've been, you know, keeping it in your pocket off for the last couple of weeks, you're actually on a v6 only. You don't have any v4 on your phones. So I don't know if you were aware of that, but we really reached the point here where that everybody talks about that we want to do, right? We want to create the v6 only network, and we don't want the consumer to even be aware of the fact that they're on a v6 only network. So it's pretty cool. I think this is a huge accomplishment. We have 10 million something IPv6 only iPhones out there today, right? This is not something we're going to turn on in the future. This is today, right now, already there. And then I'm going to share some best practices and learning from some of the stuff we did here lately as we turn on v6. Our customer base is fairly easy to handle because we have 2 types of operating systems in our network, give or take. There's some Windows phones and some Blackberries and some other stuff perhaps. But in general, it's Apple iPhones and there's Android phones. And both of them have been pretty helpful in terms of enabling IPv6 on their operating system. So Apple in 2005 started to announce that they're going to transition to an IPv6 only network service starting in iOS 9. And in last summer, they announced that all applications submitted to the App Store have to have v6 only capabilities. So that's really helped us tremendously because it's not us now just bitching to people about they need to get their apps to function over v6, but it's Apple as well helping with that and testing all the applications that come into the App Store that they're actually v6 capable. And for Android, from 4.3, they've had support for IPv6 with this technology called 464 XLAT, and I'm going to go through the details on exactly how that works. So looking at our IPv6 journey and our progress towards IPv6, once Android 4.3 was released in July of 2013, we had handsets that could go v6 only using this technology. And at Apricot 37, Cameron was the speaker and talked about this, and at that point we had about 16% adoption rate for handsets that are capable of doing connectivity over v6. So this is from the worldIPlaunch.org site, so you have the link there. You can go in and see. They're tracking some of the larger service providers and some other universities and stuff. You can see how many connections that they do over v6 versus v4. Then at the Nanox 61, I believe that one was in Bellevue in 2014, we were up to 27%. In Nanox 64, which about a year later in 2015, we were up to 54%. And I'm happy to announce now we're at 84% adoption on our handsets of v6 capabilities. So that includes anything that can communicate over v6. So there's a bunch of sites that are having some kind of small little JavaScript or something on their sites, and they can measure whether you connect over v4 or v6, and then they report that back to this IPv6 World IPv6 Launch site. So that's pretty impressive. And if you look there, you're going to see there's some smaller players there with like 99.5% v6 capabilities. But other than that, if you look at the larger ones, there's really three that sticks out. It's T-Mobile, and we're using DNS64 464 XLAT predominantly, and we're doing some v6 only stuff on the iPhones. And there's Verizon, which, as far as I understand, they're doing mostly dual stack, but they have a pretty high adoption rate in the same kind of 80, 85 range. And then there's Reliance in India, which is a new player on the market that very quickly, they brought everything kind of v6 from right off the gate. So they have somewhere 75% adoption rate as well. So those are really the main three players that are doing v6. But it's us and Reliance really that are doing v6 only and doing DNS64, which is really taking it to the next level because removing v4 from our network entirely. So 84%, but what are we really measuring here? So again, we're measuring if a handset are capable of connecting over v6 or if a handset is just connecting over v4. So it doesn't say whether this is a v6 only device or whether it's a dual stack device. So you're unable to know that by these measurements. Looking at the remaining 16% that we don't have v6 enabled yet, it could be a really old handset. So if you have a really old iPhone or you have something before Android 4.3, then you might not be v6 capable at all with those devices. Also, if you do tethering, so if you turn on a mobile hotspot on your phone and then you connect your laptop to that mobile hotspot, you're going to get both the v4 and v6 address. And we'll see that hopefully in the demo. Perhaps depending on how that works, I got to think about that. We're probably going to see how AT&T does it in the demo, but we'll see if we get a v4 or maybe we get only a v4 from Dan's iPhone. It'll be interesting. In our environment, you'll get both a v4 and v6, and you'll go through double NAT in that case. So you'll actually be NATed by your phone, and then you'll be NATed one more time when you go out on the internet. So isn't that great, Owen? Double NAT. That's what we want. Some tablets that we sell with the LTE modems built into them, they also get both v4 and v6. They're v4 only. And MVNO, so mobile virtual network operators. So somebody that's operating within our network like a track phone, they might have devices that are v4. It's kind of outside of our control if they're v4 or v6. Some IoT devices, there's a lot of talks about IoT devices actually. We have some of our devices, they just kind of communicate upstream, so they never need anybody communicate to them really, so we can give them, they've just gotten v4 addresses. You know, it might change, but today that's how it is. And then we might see, if we look at the statistics of the 60%, it might be some retries, right? So it might be for one or another reason, an IPv6 packet got dropped and it retried over v4. And you know, it could happen, especially when you talk about communicate over the ether. So that's the remaining 16. So I don't think we're going to see much more progress. If you look 2 months from now or something on this site, we're probably going to be maybe at 85% or 86%. But the long tail now of old handsets that grandma got in 2001 is going to take a while before we burn all those out, right? So we're going to be stuck around here. But really, we're not focusing that much on this anymore. What we're focusing on is to get rid of dual stack and v4 only capable devices and move to v6 only. So DNS64, NAT64, it's been out for a while. RFC 61, 46, and 47. I think one of them describes the NAT component and another one describes the DNS component. But really how it works is that the handset starts off by doing a DNS query, and the DNS device there in the lower and it gets a quad A query, and it tries to go out to the internet and see if there's a quad A record for this particular website, whatever this consumer wants to use. And if there is, we're good to go. We can just give that quad A record back, and the handset goes out directly to the internet. If there is no quad A record, then we would have to do a little lie here, right? So inside of DNS, we're appending a prefix, and we're doing the 192.0.0.1 in this example. It becomes, and if you do the math and convert to hex, you'll see that C000101 is actually the translation there. And then we append the NAT64 prefix. So the client gets this v6 address. Oh, wow, great. This site had a v6 address. I'm going to try to connect. And then we route that whole prefix to our NAT64 devices. And then we strip the header and convert it back to v4 and push that out on the internet. So that's the red path here. That's the more expensive path. We're doing NAT for anything v4. We're doing NAT for anything that goes out v4, so to say. So and these boxes are pretty expensive, and we have a ton of those, right? So and we need 2 on each site. They need to keep state, right? Because you got to remember what v6 address belonged to what session, all that kind of stuff, right? So we're spending a good amount of money, and there's complexity here, right? So as we can burn down and move people over to v6, that's a much simpler path for us, and eventually, hopefully, at least we don't have to upgrade those devices as we get more customers. And hopefully at some point we can even remove them, or just maybe have a few of them in our network instead of, right now we have them in every MSO, we call it, every landing spot, if you wish. Once you get over the ether, we have a pair of those devices everywhere. So pretty expensive. So that's how DNS64 works. When this came out, then people thought that this is going to work, but there's so many broken applications and so many broken websites with IPv4 literals and stuff in there that pretty quickly it was determined that we can't do this to our customers because too much stuff breaks. And Cameron, along with some other people, came up with this 464 XLAT. So he's one of the author of the 464 XLAT RFC. And really what it does is, and I hope you can see, it's kind of small there, but if you have 2 different, you have your v4 and v6 interface. So when we look at this in the demo, you'll see you'll have 2 interfaces on my Android device here. So you'll have a v6 regular address, and then you'll have a v4 address. It's like a 192, some RFC 1918 style address. So the handset believes it has both the v4 and v6 address. So it's going to do quad A and A record queries to the DNS. It's going to prefer the v6, try to push it out there. But if it fails, it's going to try to communicate over v4. And what it does is it's a simple little daemon within the Android device that takes this v4 and just kind of converts it to a v6. So it's doing the NAT64, or the DNS64, I should say, inside of the handset. So let's say you go to a website that's v6 capable, but there's an image in there or something with a v4 hard-coded IP address. Then that will fail down into the CLAT daemon, and the CLAT daemon will take that DNS64 prefix 64FF, whatever that was, and do that conversion for you, and then just push that out to our NAT64 devices. So all the transport goes over v6. And then we're doing the translation here in what we call a plat server. This is essentially our NAT64 gateways.
So this is only needed for hard-coded IPs, hard-coded IP4 IPs?
Yeah, so the question was if this is only needed for hard-coded IPv4 addresses. And the answer is yes. I mean, it would be, yeah, that's the only, what also could be retries, right? So you try happy eyeball style, and we'll talk a little bit about that. So for some reason, you get your v6 packet dropped, then you have a v4 address you can go to. So you'll try that as your secondary option as well.
It's been resolved for that. I got you.
Yeah. Okay, yeah. But for the handset, for the Android device here, it looks like it's dual stack. It looks like it has two addresses. It's going to use them just like any dual stack address. It's going to prefer v6. If it bumps into a problem, or if there's v4 hard-coded addresses, it's going to start using the v4 interface. And then the CLAT daemon is going to do the translation. It's going to go over our v6 only network to the NAT64 device. We translate it back to v4 and pushes it out on the internet. There's also an additional RFC 7050 discovery of IPv6 prefixes that's being used because not everybody is using the default prefix. If you use the default 64 blah blah prefix that's assigned, then you got to anycast that from all your NAT64 gateways, right? Which you might not want to do that. So you might want to have different, like for example, for us, we have different NAT64 prefixes depending on where you are in the network. What you can do now with the discovery of IPv6 prefixes, this is built in an Android device. What it does at boot time, it sends a query for IPv4 only.arpa, which is there, and it's v4 only, so it's like 192.0.0.1.0.0.2, something like that. And then from there, you can extract the NAT64, the prefix, right? Because he's removed the v4 component, you got the v6 prefix, and that's what you can use now for the CLAT inside of the Android device, right? So this happens during startup of 464 XLAT capable devices, just to simplify. You can hard code, or we could provision this stuff, right? But we don't want to do that in hard code stuff. You know, it's much easier to do it in an automated fashion as you boot up. And then there's the happy eyeball. So once people started to do dual stack, or like we did, pretty quickly people determined that the fallback to v4 take an unreasonable amount of time, because the sorting algorithm is that, before happy eyeball, the sorting algorithm was if you get v4 and v6 back, you should try all the different v6 combinations before you start trying v4. So if you have multiple interfaces, and it's a little bit of a mess, and it could be up to like 2 minutes or something like that before you actually try the v4, which is way too long for any consumer to wait 2 minutes to fail back. So happy eyeball was created to fall back to v4 after a more reasonable time instead. And that works very well in dual stack style environment and for 464 XLAT type of clients that we have in our network, because there's a v4 to fall back on. So it works very well. So keep in mind here that happy eyeballs does not work at all, has no effect at all on a v6 only device, because there's nothing to fall back on. It didn't even query for a record. It only queried for a quad A record. So it only got the quad A record. Even if it's a synthetic quad A record that we came up with, there's nothing to fall back on. So there is a new version of happy eyeballs that were discussed on the v6 Ops mailing list and in the last IETF meeting in Chicago. I wasn't there myself. But I personally, and this is driven by a couple of engineers from Apple, personally I think it's a little bit of a waste of time, because we don't want to try to improve more on the dual stack side. Like really, we should focus on trying to improve the experience for v6 only handsets instead, as opposed to trying to improve something for dual stack handsets. So I feel like they're wasting their time a little bit, and they're kicking the can down the road, because when we go v6 only, we have to pick up all the stuff that happy eyeball is protecting. So there's plenty of sites out there, and I'll show you a couple of examples on large corporations that you would be super surprised that they don't have this figured out yet. there's plenty of sites that right now they route to nowhere on v6. And Happy Eyeball is helping them because after a couple of seconds, or half a second, whatever the timer is set to, they fall back to v4 and it works. So they probably don't even know that they have this problem. And we've been trying to reach out to some of them and we've been trying to fix it, but it's like an uphill battle, right, to try to fix the internet from stupid stuff, right? If you put : : 1 in your DNS for quad A record, it's not going to work, I can't help you. Right. So we'll see examples. We'll see examples here. But to me, I feel like it's a little bit of a waste of time to do this. I'd rather have them focus on v6 only and make sure that they're, everything is RFC compliant and works in v6 only, and outreach things like this to convince people that this is important. And there's 10 million iPhones today that are v6 only. So it's not like, yeah, we had that stuff in there, and we tested it out on our web server, and it didn't work, and we haven't removed it yet. Yeah, you're going to break 10 million. If you're okay with breaking 10 million iPhones from T-Mobile network, then keep it in there. If you want it to work, then you better either have no IPv6 there, so we can do the synthetic DNS64 for you, and we'll translate it for you. And it's not a great option because it costs money for us. But either have no IPv6 quad A record, or if you have one, make sure it works. There is actually some saving grace here for IPv6 only handsets. And this is a little bit undocumented, and I'm sure Apple is working on this. And there's some other things that they can do. But there is an application level fallback capabilities within an iPhone. So if you go and again, really small here, but if you download this and you click on this link here, it goes to the development site for Apple and how they recommend you to make sure you're v6 compatible. And there's, in an iPhone, there's, you have the regular more low-level socket API things that I think all of us that, are familiar with open sockets and ports and all that kind of stuff. But there's also the higher level APIs inside of the iPhone. NS URL session is one of them, and they are marked in blue here. So if your application can use them as opposed to open the sockets and try to do it with the low-level sockets, there is actually some mechanism there to translate. So if this NS URL session encounters a v4 literal, or you pop in a v4 there, it's going to actually do kind of similar to what the 464 is doing. It's going to send out the query for IPv4 only, so it knows the DNS64 prefix, and it's going to do that translation for you, send it and translate back. So there is an application level kind of help here for some of the stupidity that's out there, and that's why that's saving some of the user failure scenarios is being saved by that. But there's and this handles the IPv4 literals. If you have a v4, if you pop in something with just a v4 address, stuff like that. But there's no fallback if IPv6 fails. There's no Happy Eyeball style that we're familiar with in the dual stack environment. So that's why we have some failure scenarios on iPhones that we haven't seen on on dual stack clients. So that's why I think it's useless to try to. There is no Happy Eyeball, so it's useless to try to improve that algorithm anymore. That algorithm can die away with it's good enough as it is. I haven't heard anybody complaining that it takes too long before we fail over back to v4. And if you have a complaint about that, let me know, because I haven't heard anybody with that problem. And it should be visible, in my opinion. It should probably be a longer timeout, maybe a 5-second timeout or something, so people fix their stuff, right? So it really works. So I want to do a little bit of a demo, just show some of the interfaces that we have on the phone here. So I'm going to switch over to see if this works. This is a little bit of it looks like it works actually. This is a little bit of an experiment, as I said. But I'm using this network info 2 here. So from this one, you can see the interfaces that I currently have. And you can see there that's the wireless LAN 172.20. So this is the one that's connected to Dan's phone for tethering. I had to do that to be able to do the Chromecasts. I had to tether with somebody. So apparently, in this case, AT&T, they only hand out the v4 address when you do tethering. In our case, you would have seen on the wireless line, we have two addresses here. You see v4 and a v6 address. And then the RMNet, this is actually interesting. This you would think is the network address to T-Mobile, but it's actually not. This is the voice over LTE address. So for voice over LTE, when you make a phone call from your T-Mobile handset, it actually goes over IPv6. So the voice over LTE is all v6 for modern handsets. So if I enable, I should be able to get, if I go in here, why don't I have normally if I'm not tethered like this, I would have also an RMNet 0, and that would be my v6 my v6 LTE interface, data interface. So I would have two, one for data, and then you would also see a 192 something. I don't know if somebody with a T-Mobile handset can pull this up, but you'll see like a 192.0.0.2 or something, or 192.0.0.2 or something like that. That would be the NAT64, the 464 XLAT. That would be the 464 XLAT interface. So there's actually, with 464 XLAT, there's an extra interface, which is the v4 interface. So the Android phone doesn't really distinguish between doesn't really distinguish between a dual stack or a 464 XLAT. There's two interfaces, and you can pick one of them to use. So that's that. Going back to my PowerPoint here. And it's a little crappy because I'm tethered, so I can't. I would want to show you also when I turn on tethering on T-Mobile, I do get both the v4 and a v6 address. And you can see it here, right? So this is how it would look like with full, all the interfaces that can potentially show up. So you have the tethered v4 addresses, and you have your IPv6 data interface. You have the voice over LTE IPv6. So when you make a phone call, it goes over that. And then you have the Wi-Fi address. In this case, this Wi-Fi, this is from T-Mobile corporate when I did this. And we don't have v6 on our Wi-Fi, so I only get the v4 on our Wi-Fi. And then we have the 464 XLAT address, which is, I think, 192.0.0.2 if I remember correctly. But it works like any other v6 interface. So these are all the interface that you get on an Android phone in a T-Mobile network. If you had an iPhone, you would not have this 464 XLAT, right? Because it's v6 only. So if you're using 10.3 or higher, then it's v6 only, so there's only v6 interface. So as we did this, there's certainly failure scenarios in v6 that you perhaps don't see in a dual stack environment. And you can categorize them into two groups. There's the network-related failures, and there's the DNS-related failures. The network-related failures, it's two categories really here. Special use case, somebody who puts a : : 1, and I have no idea why people do that. If somebody can come up with any good reason for putting : : 1 in your DNS for your Quad A record, let me know, because I have yet to figure out. But it's pretty common, actually, you should see. And there's a great Dan Wing, I think it worked for Cisco, but I might be wrong. But if you follow this link here, you can see he scans the Alexa like top 25,000 or something every day. And you can see there's like 4 sites that constantly, they're using like a link local in there. And there's about 100 or something sites that they're just routing to nowhere. They have a v6 in there, but you cannot connect to that v6, right? And that causes problems. So with Happy Eyeball, you do the fallback and all that stuff. It's kind of invisible, but once you turn on v6, this becomes a problem. One example, my favorite, and I feel kind of ashamed, I'm from Sweden originally, and Ericsson is we're proud of Ericsson in Sweden. But www.ericsson.se, you cannot get to that site from a T-Mobile Apple phone. So if somebody has an Apple phone and want to try, please go ahead and you guys can confirm. www, if you do it with the www, if you do it with the Ericsson SE, then it's redirected to some com, blah, blah. But www.ericsson.se doesn't work. And the same thing with here.com, which is a map. This used to be the Nokia maps, and they sold it to BMW and Audi and what have you. But these sites, they don't work. And we're not going to fix them either. And I'm going to go to the conclusion soon here. This is something we can't help them, right? If they put something that doesn't route, V6 only, tough luck. The good news about the network-related failure is that they're fairly easy to troubleshoot. You can have a fairly junior engineer to look into this, and you can quickly see, okay, what address do trace route is not routing anywhere. This is basic network connectivity stuff that's pretty easy to see, right? So that makes the network-related failures easy to troubleshoot. But they're much more common than the DNS-related failures. The DNS-related failures, though, they're much harder to troubleshoot. You probably need to be like me, kind of a DNS geek, to figure out what the hell happened and why is this not working. And there are 4 different DNS-related failure categories. And they're pretty deep into the DNS weeds here with flags and stuff, but I'll go through them just real quickly. The R code, so if there's no IPv6 address, there's no quad A record, then the R code that the DNS server is supposed to send back, if I ask, Microsoft.com, I ask for www.microsoft.com quad A, they're supposed to send me back what's called empty nowhere, an empty record saying there's no quad A, but there's an A record here. And that'll trigger the retry over A to fetch that A record and then do the synthetic thing in the DNS64. And also in the RFC for DNS64, they said, well, there's a lot of buggy stuff out there that sends out NX domain instead, which is very similar return code. The only difference is that NX domain say, there's nothing here at all, so you don't even have to make an additional query. But some people send that out for a V6 address, even though there is an A record on that same label. And so NX domain typically works with DNS servers, but if you do another R code outside of NX domain or empty no error, it fails. It never retries. Even though the RFC, the DNS64 RFC says you should retry for any R code. The DNS servers in general doesn't do that. So there we're bumping into a problem there, and something for ISC, I see some people from there, something you guys I think should look into, because I know a lot of people are using your DNS, and there are some corner cases here that doesn't work with bind. Another interesting scenario is the SOA record. So when you send this empty no error back, you also send what's called a start of authority record back. So if I asked for www.example.com, the SOA record is supposed to be for example.com, the domain that I asked for essentially. But a lot of load balancers and stuff have this broken. They send something else back, or if it's if you ask for a.b.c.f.com, whatever, they just send f.com back or something like that. So they're improperly configured. And this also derails DNS64 in some cases, where we just return server back to the client and the client is unable to connect. And there's an example on the R code. I have an example up there. This one we scanned in advance a little bit to figure out if we can see anybody with problems. There was one photo site, a German photo site that experienced this problem. We're unable to reach it on a V6 handset. And we reached out to them, and they were super happy. I managed to get to the right people, and he said, oh, we'll fix it. And 2 days later, they've had it fixed and everything, and they were super happy that we reached out to them and tell them that this is not going to work in a couple of weeks from now. So I'm not gonna say who that was, but they did a good job. Another corner case are flags. When the authoritative server, example.com, returns a DNS answer, it's supposed to have this AA flag saying I'm authoritative for this DNS response. again, some kind of funky load balancers and stuff, they don't have that AA flag in, and that tricks our DNS64 server to say, okay, well, if you're not authoritative for this, I can't trust it, so I'll send back a serve fail to the client. We had a major cloud storage provider, if you wish, app, like a famous one. You would know who it is if I told you. Having this problem, and thankfully we caught it and worked together with them to fix it. But here, this requires pretty deep DNS skills to go in and troubleshoot. This is not, you can put some, engineer out of college to try to figure this out. You need to have some experience here to figure this out. And hopefully this will help a little bit if you guys ever go v6 only and you have issues with this. You can probably categorize them into these 6 different categories. I'm thinking of creating a site also where you can pop in a domain and it will tell you if there's any DNS64 related problems with this domain to help with this type of troubleshooting. I have some early stuff up and running, but I haven't gotten to that. So maybe next meeting we have, I can present that. And these are kind of all very rare. The most common scenario from a DNS-related failure is it simply doesn't return anything for a quad A record. So you send a quad A query and you just get crickets in response, nothing. This also tricks our DNS64 servers just saying, okay, fine. There's no v6 to timeout, send serve fail back to client and you won't be able to connect. Here's another example, www.sky.com.mx. You are unable to reach that site from a v6 handset in T-Mobile. And we've been trying to reach out to them. I don't know how common, this is something we found in our scans ourselves, so I don't know how common, if this is some streaming, it looks like some kind of ISP in Mexico, so I don't know how common it is for our client base to actually go there. But it doesn't work if they wanted to do it, right? So you had to turn off v6. And by the way, in 10.3, there is an option for you in your iPhone to turn off v6. And that's something that we wanted to have in there, actually. And we worked with Apple on that, so that if we encounter somebody with problems, at least they can just turn off v6 and be done with it, right? And then we'll kick the can down the road, but at least the client is happy. Because we've had a few people calling us. We actually went v6, and then we rolled back, and we went v6 again, and we rolled back. And now the third time, about 3 weeks ago, we went v6, and we're probably not going to roll that back. But we had some issues, and the last time we rolled back was, we had a few people complaining about not being able to connect. And it was like funky VPN, kind of their own homegrown apps. It wasn't one of the major, websites, but load balancer are notorious for just not working as you would expect them. And this is really hard to troubleshoot. And it ends up being, well, it works on my Verizon phone, but it doesn't work on my T-Mobile phone. So it's got to be a T-Mobile problem, right? And then, you have that first, we have, so many customers, right? And we have like the first level of support. And once it comes down to me and my group and the people that are capable of troubleshooting this, it might take a while and it might be hard to get to that stage, right? So these are some of the failure scenarios that we've experienced. So really some learnings here that I want to share with everybody. So, and I'm sure everybody here in the room at some point will move away from dual stack and move to v6 only, right? So at some point, whether it's around 50% of your traffic is, v4 or 95%, whatever your threshold is, when you say, hey, I want to get rid of this v4 junk, right? But at some point you want to do it, but you still want to be able to connect to those grandma's blog, whatever that is, that's still on v4. So, so some advice when you do that. And by the way, I was looking in one of our border routers just to see where do we still see v4 traffic, what type of sites do we still see v4 traffic to. And I can't drill down, to URL type of level because I don't want to go into our network, to our traffic and do that kind of statistics. But more from an AS perspective, we can see where we send most of the traffic. And it's interesting, it's mostly interesting is to see who is not there. There's Google is not there, Netflix not there. They've been doing a good job, going v6 only. Cloudflare is another one that they're going v6 only. Even if you haven't requested it as a client, you still will get v6 from Cloudflare, as far as I understand. And I think there's somebody from Cloudflare who can elaborate on that later. We see CDNs, the smaller kind of CDNs, Verizon, Edgecast, Fastly, those kinds of people. They have a lot of clients, a lot of sites using them, and we see a lot of v4 traffic going there. We see a lot of traffic to Comcast, which I was scratching my head for a while, because Comcast is more like us, an eyeball type of network, right? So why would people communicate between the Comcast and T-Mobile? It turns out that when we looked at this a little deeper, some of our stores are actually connected to Comcast, and we're using VPN back, and they're shoveling quite a bit of traffic, so that kind of showed up there. And then also, if you have like a summer home or something like that, and you maybe have poor connectivity, you're out in the boonies, but you have Comcast there, you can go to one of our stores, you can pick up one of those femtocells, and you plug those in there. And then once you do that, and your handset attached to that, all the traffic's gonna go over that femtocell, and it's gonna be tunneled back to us. Some Wi-Fi calling and some other stuff like that. So it actually adds up to quite a bit of traffic from Comcast. But Comcast is dual stacked, right? So that was one thing for me, being responsible for the architecture and the stuff that we work on at T-Mobile. Moving forward, we got to make sure that like our IPsec VPN, we should be able to also have a v6 capabilities there, so we can do that over v6, right? And all the femtocells, like what can we do with them? It's a little complex because there's a lot of different components, and Nokia is in there, and but like that kind of stuff is what I'm going to work on. We've really done all we can here on the handset part of things, and what we're going to work on now is those kind of corner cases. Also, we've seen what both Microsoft and Cisco announced about going v6 only in their campuses on their Wi-Fi and stuff like that. So we're going to try to spin that up as well and do that. We're behind kind of on the corporate IT side versus what we're doing on the handset side. But overall, we're at 84% v6 capable devices, and don't expect us to, we can't do much more, right? We can move the needle to 86, 87, but we're pretty much where there's no more we can do. So what we did, really determine what sites and apps are important to you, right? So don't try to solve all the problems in the world, and don't let some stupid site on the other side of the world that's totally unrelated to what you're doing hold you hostage for your v6 deployment, right? I was super scared in the beginning, and it's actually Cameron kind of convinced me to relax. Because I like, oh shit, there's some Chinese site that doesn't work, let's stop this whole madness. Like, no, it doesn't matter, like nobody's gonna complain about this site, and they need to fix it. There's nothing broken on our side. We're RFC compliant. They need to fix it on their side, right? We did proactive scanning of some of the top sites, even though it's hard because it's not only www.whatever.com, it's load balancers and it's hard. How do we scan this? Reach out. If you can reach out, find in Whois or with the SOA record in DNS. There usually is a name there, email address. You can try to reach out to people. I had 2 university EDU sites that were broken that I reached out to. Both of them fixed it within 2 days. So as long as you reach the right people and they respond to you, they're very happy to hear from you. And we tell them that 10 million iPhones can't reach their site in a couple of weeks. They're pretty eager to fix it. So that's been great, actually. Local overrides. We actually, another site that we had that was broken was a big Visa type of credit card issuer. It wasn't Visa, but I don't want to tell you who it is because they fixed it. But it was a pretty big, and I was scared because this one would potentially have impact when we turn on v6. And for a while there, we tried to reach out to them. We didn't get a response from them. So it's like, what do we do now? Like, we have these massive, and it was not only one site, it was like 20 different kind of credit card related sites that were broken, we could see, and all of them related to the same DNS servers. And what do we do? And one idea we had for a while that I came up with was like, why don't we put local redirects in there? Because we can put whatever we want in our own DNS, right? So we can redirect them to the v4 and override this whole thing. But as we thought about that a little bit more carefully, we realized we probably don't want to do that, and especially not without talking to the end people on the other side, right? Because if you start to redirect, credit card applications and stuff like that, you're pretty liable if, they change IP address, hacker picks up that IP address, and then all of a sudden you have 10 million iPhone customers connecting to some fake, credit card app. So my advice would be don't try to muck around too much with local overrides. And like the other side that they got the problem, they have to fix it. Scan social media for direct customer feedback. Sometimes, with a large corporation like a T-Mobile, there's so many layers of support and stuff, right? It's some of these problems are really hard to troubleshoot, and it's not easy, right? So even though you should prepare your help desk and stuff like that, but also Cameron, he's going into Reddit every day and making sure there's nobody complaining about something. And we had, you can look, we had Grindr, which is some dating app. It got broken a while back ago, and there was a lot of chatter. Oh, it works on my AT&T, doesn't work on my T-Mobile. What's going on? And we could understand what was going on there, and there was actually a problem with their app, and they fixed it eventually. But you can scan social media for more direct customer feedback to people that are perhaps more knowledgeable about IPv6. And don't try to change the world. Like, don't let some stupid site on the other side of the world hold your hostage with your IPv6 deployment. And keep things in perspective, because there's a lot of broken stuff out there. There's sites that are under attack, DDoS attacks. There's Flash that doesn't load on an iPhone, and there's stuff that looks really crappy on small screens. And there's like a million things that are broken on the internet. So to have Ericsson.se and a few other sites being broken, it's not going to move the overall needle of the brokenness. Like, stuff is just broken in there. So you got to keep that in perspective. Like, don't stop your V6 deployment just because a few sites are not working. That was my last slide. So any questions? Dan got the...
I understand when you get an Apple iOS app approved by the App Store, it must support IPv6, right? If that, let's say with the Grindr app, for example, it had to pass that test, but it failed on the network. Can you explain where the delta?
Yeah, so I think Apple, what they're doing, I don't know exactly how their test is being done, but they're just doing basic rudimentary testing. They fire up the app and they make sure it looks like it works, but they're not going to click on all your different buttons and stuff. And in this case, it was just like the messaging piece of the app that actually failed. So the overall app actually worked and stuff, and you could search and blah, blah, but once you started trying to message with somebody else, that component was the one that failed. So. All righty, well, thank you, everybody, for listening in.